functions and introductions. Linear functions are a fundamental concept in mathematics describing a straight line relationships between two variables. They form the foundation of understanding more complex functions and have numerous real-world applications. Defining linear functions. 1. Straight line relationships. Linear functions describe a constant rate of change between independent and dependent variables. 2. General form. The general form of a linear function is y m x plus b, where m is the slope and b is the y-intercept. 3. Real-world examples. Linear functions can model situations like distance traveled, cost of items, and population growth. Slope and intercept. Slope. The slope or rate of change represents the steepness of the line, and the change in y per unit change in x. Y-intercept. The y-intercept is the point where the line crosses the y-axis, indicating the starting value or base amount. Interpreting slope and intercept. Understanding the slope and intercept helps identify the function's behavior and real-world meaning. Graphing linear functions. 1. Plotting points. Identify key points on the line by subsetting values into the function equations. 2. Connection points. Draw a straight line through the plot points to visualize the linear relationships. 3. Analyzing graph. Interpret the slope and intercept from the positions and orientations of the line. Slope intercept from standard form. The slope intercept from form of a linear equation is y m x plus b, where m is the slope and b is the y-intercept. Advantage: these forms makes it easy to identify the key characteristic of the linear function and graph its application. Slope intercept form is commonly used in equations describing lines, such as in physics, economics, and engineering. Point slope form. Points. The point slope form uses a null point x1, y1 on the line and the slope m. The slope represents the rate of change between the x and y variables. Equation: the point slope form is y means y1 m x means x1, where x1 y1 is the known point. Applications of linear functions. 1. Cost functions. Linear functions can model the cost of items or service based on quantity. 2. Distance and time. Linear functions describe the relationship between distance traveled and time, such as in physics. 3. Populations growth. Linear models can approximate population change over time in certain scenarios. Linear models in real life, economic modeling supplies, demand, and pricing. This science describing relationships between physical quantities, engineering, design system and analysis performance, finance, processing, trends, and project future values. Solving linear equations. 1. Isolate the variable, rearrange the equations. 2. Get variables of interest on one side to perform operations. Use yet as inverse operation to simplify the equation and solve for the unknown. 3. Check the solutions. This is this found value back into the original equations to verify it is correct. One solution and key takeaways. Linear functions are a fundamental concept in mathematics with disparate applications. Understanding their properties such as slope and intercept and mastering their graphing and solving techniques is critical for success in various fields.